I am Sarala, Associate Professor of EEE Department from SKR College of Engineering, Chennai. So today I am going to explain about the operation of the stepper motor. Before that, we'll see what is an electrical motor. So we know the electrical motor, it converts the electrical energy into the mechanical energy. Based on that, we have two types of the electrical motor. It is classified into DC motor and the AC motor. In the case of the DC motor, the input given will be the DC supply, which is converted into the mechanical rotation, whereas in the AC motor, the input given will be the AC supply, which is converted into the mechanical energy. Then we'll see what is a stepper motor. So stepper motor, it is a special type of the electrical motor which makes use of the input DC, but the output will be in the form of the mechanical rotation, which is a step output. So the stepper motor is a brushless DC electric motor which is going to convert the full rotation into the angular movement. Based on this principle, we have various types of the applications of stepper motor. So here the few applications are listed. So it is used in the old dot matrix printer, then in the industrial automation and mainly in robotics, and also in the design of the CNC machine. So it is the computer numeric control machine. And this is a diagram for the two-phase permanent magnet stepper motor. So first we'll see the construction of the stepper motor. So it consists of the outer motor case and then the stator. So it is shown with the 4 pole magnets, and inside that there will be a permanent magnet rotor. And the shaft will be connected with this permanent magnet rotor through which the output is taken. So next we'll see the operation of this stepper motor. So we have again various types of the stepper motor. So based on the number of steps, so we can calculate the step angle. The total 360 degrees into the number of steps will give the step angle. So in this case, there are 4 pole magnets, and inside that the permanent magnet rotor is situated. So initially, the stepper motor is driven by the excitation pulses, that is the input DC supply is given in the form of the pulses. So these pulses are generated by the controller circuit, so which may be a microcontroller circuit, and then the motor moves in steps according to the given sequence. So here we can see the operation of the stepper motor. So we have the 4 pole magnets and the rotor is a permanent magnet. So the outer pole magnets, it is of electromagnetic type. So the coil is wound over the magnet whenever the supply is given to the winding in each phase. So it acts as a magnet only at that time. So initially in step 1, the phase A winding is supplied with the DC supply. So therefore the rotor position, the north pole, will be towards the phase A. So then when we want to change the position of the rotor, then the supply is given to the phase B. So the supply which is given to phase A is cut, and then it is given to phase B. So in that case, that particular magnet will act, electromagnet will act as a magnet and produces the flux, and therefore the rotor will move from the first position to the next position. So in this case, the angle is 90 degrees. Since there are 4 poles, so we calculate the step angle is 360 by 4, therefore we get 90 degrees. Suppose when we want to change the step angle, then we have to have more number of the poles in the stator. So next in the next case, again when the supply is changed from phase B to phase A dash, again the rotor will go through another rotation of 90 degrees, and similarly in the last case. So here the input given to the stepper motor, it is in the form of the pulses. So how we are going to provide the pulse? The input is a DC supply, but it can be converted into the pulses by using the driver's circuit. So this is the driver's circuit for the stepper motor. Here we can see 4 transistors Q1, Q2, Q3 and Q4, which acts as the power semiconductor switches through which each magnet winding will be connected to the transistor. So initially when the phase A winding has to be supplied with some voltage, then we have to turn on the transistor Q1 by applying the base current to the transistor Q1. So therefore the transistor Q1, it will be turned on and the supply is given to phase A. Then when the supply is cut or when the base current is removed to the transistor Q1, it gets turned off and then the supply is given to the transistor Q2. Therefore next phase B will get the supply and therefore there will be a movement of the rotor. So like that we can give the supply to all the 4 poles in the case of the 2-phase permanent magnet stepper motor, which is shown here. So we have the complete rotation which is divided into the number of steps. So based on that we have the angle of rotation. So in this case it is 90 degrees. Suppose when we change the number of steps into 6, then the step angle can be converted into 60 degrees. So this is how a stepper motor is operated and we can use it in various applications. Thank you.